In statistics, conditional probability means that a condition has happened. So when we come back and look at our tea and coffee drinking example, we know that the probability of a student being a tea drinker from our table up here is 3 out of 10. It's 0.3. However, we also know that that is very different depending on their coffee drinking behaviour. Now that's the condition. Okay, so we're interested in one event, drinking tea, but if we consider the overlap with coffee, we can consider it as something occurring beforehand. For example, the overall drinking tea is 0.3 for the total for the 10 people in our class. But if we look at our splits here, the probability of drinking tea here is a quarter, 25%. But the condition here is that the person is a coffee drinker. That's really all that is the condition. And over here, the probability of drinking tea is as high as 0.667, or 2/3, if they don't drink coffee. So in a way, this is kind of like a weighted average, a special average, but it's the overall tea. And conditional probability is just this. Over here, the probability of drinking tea given that the person drinks coffee, that's the 0.25. Okay, so we write it, the probability of drinking tea given that the person drinks coffee is 0.25, so it's lower. So that's the conditional part, that's the if part. Down the bottom here, we can label this branch the probability of drinking tea given that they don't drink coffee. So the probability of drinking tea if a person does not drink coffee or coming from the non-coffee group is actually 0.67. And that's the notation. That's all there is to it. Let's fill these branches up so we can see how the conditional equation works. The important thing here is that the condition doesn't happen at the end. What's on at the end? The end, this 0.042 here, is the probability of coffee and tea, and this 0.38 here is the probability of coffee and not tea. So these are the ands at the end, and the conditional probability happens in the middle of the tree, not at the beginning or the end, but in the middle, after the first event has happened. So coming back to labeling this tree here, this fourth branch down, this 0.33, can also be labelled as the probability of not drinking tea given not drinking coffee. And the 0.75, the probability not tea given drinks coffee. So they all have their very specific labelling. So conditional probability is a little bit like a filter, and when we look at our table here, the probability of drinking tea given drinking coffee is 1 out of 4. We ignore the other 6 people, we ignore the total, because we've already filtered it by the coffee drinkers. So if we just hone in on the coffee drinkers, the 4 of them, the probability of drinking tea is a quarter. Okay, and I think I said that in the beginning, I'm just saying it a different way. This column here is for the non-drinking coffee, and the probability that they drink tea is 2 out of 6. That's why it was 0.67. Now just remember that when we look at the AND event at the end, we got there by multiplying 0.4 times 0.25. So we multiply along the branches to get the event at the end. Usually we don't know the conditional probability that we're trying to work out, but we're given the AND. It's in the question. It will tell us the probability that a student likes both coffee and tea is such and such. So they'll give us this value, and normally they'll give us this value, or we might have worked it out from a previous step. Now just alert you to the question here. We're just coming back to the first one we looked at. What percentage of students don't drink tea if they drink coffee? Now that's actually a bit of a backwards sentence. It's a good English sentence, but in terms of the events and the way things have happened, what we are asking is actually this. Given a group of students who drink coffee, what's the percentage or the proportion or the probability that a student doesn't drink tea? Okay, so given we've decided whether, or we've worked out whether they drink coffee or not, and in this case they do drink coffee, from this group, what's the proportion that doesn't drink tea? So we have to be careful when we look at the sentences to note what it is we're asking or being asked about. In this case, it's please tell me the chance or the probability that a student does not drink tea given that they're a coffee drinker, given that that's already happened here. So as we understand that the ends of the branches is the multiplication through the centres of the branches, we can work it out this way. What is the probability of not drinking tea if a student drinks coffee? So we were here, drinks coffee has happened, given that's already happened. The probability of drinking tea this is the one that we have to find out. So let's just highlight that that's what we're being asked for. We probably don't know the 0.75, but the way that we can mathematically work this out is look at this value here, which is probability coffee and not tea. And since we arrived at that by multiplying through the branches, 0.4 times 0.75 to give us that, we now just divide to work out that 0.308 divided by the 0.4 will give us the 0.75. So probability coffee and not tea divided by probability of coffee, the condition. That there is our conditional formula, our equation, that we can pick out what it is we're being asked to work out and then apply these values here. Now this is all in notation which you need to be a little bit familiar with if you're going to use this equation to work it out. You don't have to use the equation. There's other logical ways of working it out from the tree and so on. But let's just go with this. So if we knew, and we're probably told, that the probability of drinking coffee but not tea is 0.308, and the probability of drinking coffee regardless of anything else, so that's the coffee club, is 0.4, we can divide 0.308 by 0.4 and we'll get the 0.75. So we will arrive at the proportion of people who drink tea, or don't drink tea, sorry, who are coffee drinkers.